packaging tool from python.org. Now, a lot of teams and companies are switching over from pip to pipenv, so it's definitely a nice tool to learn. Basically, it is combining the features of pip and virtual env. So first, let's go over both pip and virtual env in case either of those are unfamiliar to anyone. Now, I'd say anyone watching this video who has done any Python work beyond the basics has most likely used pip. But basically, pip is a way for us to install additional packages that allows us to add a ton of functionality that doesn't exist in the Python standard library. So for example, if you want to do some image manipulation, then Python might not have the best tools available right out of the box, but you can use pip to install the pillow library and use that to work with images. So I'd guess that a lot of people have probably seen pip before, but I'd say fewer people have used virtual environments. Now that's a topic that a lot of people mean to learn eventually, but never really get around to it. But basically, a virtual environment is a way for us to have a specific environment for each project or application that we're building. So for example, you could have one application that runs off of Python 2.7 and Django 1.5, and then another project that runs with Python 3.7 and Django 2.1. So each of those projects would have their own version of Python and their own packages, which is usually how you want to do it. Some people put off learning virtual environments and just try to run every project using their global installation of Python and all the packages installed in one place. But if you do it that way, then as soon as you update to the next version of Python or update your packages, then it could break some of your older applications that were running just fine. So it's best to split those up using virtual environments. So before pipenv, we used pip to handle package management and used virtual env to handle virtual environments. But now with pipenv, these can all be handled by one tool that simplifies the process. So let's get started and see what this looks like. So first, we want to install pipenv, and we can simply install pipenv by using pip. So we can just say pip install pipenv. And you can see that mine says requirement already satisfied because I've already installed it, but yours should install there. So now I'm going to clear the screen. Okay, and once that's installed, let's pretend that we're starting a new project so that we can see how we can install packages for that project and also create a virtual environment automatically. So I've created a directory on my desktop called My Project. Now you can have a project folder located anywhere, but this is the one that I'm going to be using in this video. So you can create an empty folder like I've done here, or you can also use pipenv on an existing project as well. So once you have a project or directory containing your code, let's navigate to that location within our command line. And again, I'm locating to a directory on my desktop called My Project, but you should navigate wherever your code will be located. So I'm going to cd into that directory. So I called that My Project. Now, right now, this is just an empty directory. So at this point, if we were using the old method of installing packages for this project, then at this point, we would create a virtual environment using one of the older tools to do that. And then we would need to manually activate that environment and then start installing the packages that we want to use in this project. But with pipenv, this is all built in together now. So instead of creating a new virtual environment manually, we're simply going to install the packages that we want with pipenv. So let's say that we want to use the request package for this project. If you haven't used the request library, then don't worry about it. We're really just choosing a random package to install for this project. So to install this, let's say pipenv install requests. Okay, so we can see that it did a few things there. So once that is finished, let's take a look at what this did. So right off the bat, if we scroll up here to the top where we ran that command, right after we installed requests, it first notices that we don't have a virtual environment for this project yet, so it creates one for us. We can see that here, creating a virtual env for this project. And then it gives us a location to a pip file, and we'll talk more about a pip file in just a minute. And then it says that it is using this version of Python, which is where my Python 3.7 is installed. And then it actually goes through and creates that environment for us. So if I scroll down here a little bit, we can see that it gives us the location of that virtual environment. So mine is here within this virtual env's directory. And that virtual environment that it created is actually just a regular virtual environment like you'd be used to using in the past. So you can navigate to that location and activate it manually if you'd like. But pipenv gives us simpler commands to interact with that environment than to just do it manually. Okay, and next it says that it created a pip file. The pip file is going to be a file that describes our environment and how we can build it back from scratch. So this is similar to the requirements.txt file that some of you may have used before with pip, and it actually will be a replacement for the requirements.txt file within pipenv. Now, if you've never used a requirements.txt file before, then don't worry too much about it. Basically, it just tells us which packages we have installed and what version of that package we're using. So that's what this pip file does also, but it's also more specific. So we'll actually open this in just a second, but for now, let's see what else our pipenv install command did for us. So after it said it created our pip file, then it actually installed the request package here. And that's what this whole section is doing here, where it says that it is downloading. So let's scroll past all of that. Okay, and after it finished the request installation, then it says that it added requests to our pip files packages. Then it says that this pipfile.lock was not found, so it's creating that. So pipfile.lock is another file that gets created, and it's similar to our pip file, but with some key differences that we'll see throughout the video. Basically, pipfile.lock is a file that we're not supposed to touch. It's just a file that gets generated and produces deterministic builds. And again, we'll see more about that in just a bit. Okay, so lastly, here at the bottom, we can see that it tells us that we can activate our new environment simply by saying pipenv shell. And if we just want to run a command inside that virtual environment, then we can do pipenv run. But before we activate the virtual environment, let's first look at the pip file and the pipfile.lock. I have the directory with those files open in my Sublime Text, so let's open those up and see what they look like. Now you can use whichever editor that you want in order to look at these, but I have them opened up in my Sublime Text. So I have my project open over here. So first I'm going to open up the pip file that it created, and this is the pipfile.lock. So first let's look at the pip file. Okay, so the pip file is pretty simple. The format that this is using is called TOML, T-O-M-L, which is designed to be a minimal format that mostly contains keys and values within these sections. So we have a source section here that shows where we're downloading packages from, and right here it's just pipi.org. And then here we have a packages section. We can see that it currently just contains the request package. And it says that request is equal to this asterisk here, this star. And that just means that we didn't specify a specific version when we installed request. If we had, then there would be, it would say that it's equal here to that specific version. Now this is nice because we're not specifying an exact version. So anytime we run pipenv install, it will go out and see if there are newer versions available for us. And if there are, then it will update those versions automatically. So that is something that we would have needed to do manually in the past with pip. Now, like we talked about before, updating packages like that can also be risky because we don't want to take any chances of updates breaking our project. But that is what the pipfile.lock is for, and we'll discuss more about that in just a bit. Also, if we wanted to specify an exact version of the package here in the pip file, then we could do that too, and it would just stay with that version even if a newer one is available. Okay, and lastly, we can also see down here at the bottom that we are specifying which version of Python that we're using. So I'm using Python 3.7, but we could change that if we'd like. Okay, so that is a quick overview of the pip file. It's a pretty simple file that just shows how we can create a new environment from scratch. And this file is also meant to be editable. We could add packages in here and rerun the install command, and it would install the packages that we added. And we'll see that in just a bit. But for now, let's look at the pipfile.lock. So I'm going to open up pipfile.lock. Okay, and real quick, just let me kind of scroll through here and then scroll back up. So right off the bat, we can see that this one is a bit more complicated. Now, don't be intimidated if you don't understand what a lot of this is. This is a file that we're not actually meant to change manually. This is a generated file that has more detailed information about our current environment. Now, if we scroll down here, then we can see that we have some hashes. And for the packages that are installed, we can see that we have more than just requests. So this file even contains the dependencies that are installed when we installed the request library. Now, not only that, but it has the exact version of each of these packages that were installed. So for example, if we look at requests here, then we can see that we have these hashes, but then down here, it also has the exact version. So this is the good thing about having this pipfile.lock. So this will give you a deterministic build. And what I mean by that is that this lock file will absolutely give you the exact same environment every time. And you only get a different build when you explicitly update the lock file. And we'll see how to do this in just a bit. So this gets us around the problem that we had before, where I said that updating packages can break your project. So the pip file could see a new version of your package and update them accordingly. And then once you're sure that all of your code is still working in development after you've updated those packages, then you can simply update your lock file, which will give you the exact packages that are installed at the time that you know work well. And once you update that lock file, then you can push that all to production. Okay, so now that we've actually looked over the pip file and pipfile.lock and what the differences are between those, now let's actually activate our environment and go through some other commands to see how to do all of this. So to activate our environment, I can just go back here to our command line. I'm going to clear the screen. So to activate our environment, we can simply say pip env shell. And we can see here it says launching subshell in virtual environment. Yours may not say that. If it doesn't, that's fine. But if I clear my screen here now, then that should have activated our environment for our project. Now, usually when you have an environment activated, it will add something to the beginning of your prompt in the command line. And it's doing that here. So we can see that in parentheses here, it says my project. That's the virtual environment that it created for this project. Now, if you're unfamiliar with using virtual environments, what this did was it actually put us in an environment where it will now be using a different Python interpreter and a different location for all of our packages. So for example, if I run Python now that I'm here within this environment, then we can see that it still might look the same as your default environment. It's just Python 3.7 here. But if we look at our current Python executable, we can do that by saying import sys and then sys.executable. Then we can see that the Python it's actually using is in this location here. And this is our virtual environment that it created in this virtual env directory here. So that's a good thing. That means that whatever we install in this project will be separate from our other projects on our machine, and that's what we want. So if you'd like to learn more about how these Python paths work and how to determine the location and version of your current Python interpreter, then I do have a separate video on that if you're interested. And I'll be sure to leave a link to that in the description section below. Okay, so since we also installed requests in this environment, we should also be able to import that. So if I say import requests, then we can see that it imports that without any errors. So that means that we do have it installed. Okay, so now let's go ahead and exit out of Python here, and I'll go ahead and clear my screen. So now let's say that we want to deactivate the environment. To deactivate the environment, we can simply say exit. Now there might be some confusion here that we used exit to deactivate the environment instead of using deactivate, which you might be used to using older virtual environments. Now I was confused at this too. What's even more confusing is that if you do use deactivate, then it could actually look like it does something, but it won't actually exit completely. And that's because pipenv actually launches a subshell to activate the environment. And to exit that completely, we need to use the exit command. So be sure that you do that and not deactivate. I know that can be a little confusing, but this is just how we do it. So now we no longer have that environment activated. Now we can actually run commands in our environment without activating it. So we can do that with the pipenv run command. So let's say that I want to run Python within our current environment. So we could activate the environment like we just did with pipenv shell and then run Python, or we could just simply say pipenv run Python, and that will run that Python command within that environment. So if I run that and check our executable again, sys.executable, then you can see that this Python is using our virtual environment Python. And again, just like before, we can import packages that we have installed in that environment. So I'm going to go ahead and exit out of that. Now we never actually activated our environment there, so we don't need to run exit again to get out of that environment. We're already outside of it. Now you can run scripts that way as well. I don't have a script in this current project, but if we did, then we could simply say something like pipenv run python script.py. And that would run a script using the Python that is in our environment. But that script doesn't exist, so I'll just go ahead and delete that. And let me also clear the screen here. Okay, so now let's install some more packages for this project. Now we could do them one at a time using the install command that we saw before, but let's see how to install several packages from an existing project. So for those of us who have used pip before, you're probably used to using a requirements.txt file. If you don't know what requirements.txt file is, basically it's just a list of dependencies and packages that a project needs in a little text file. So if you start using pipenv, you can still use your requirements.txt files before you completely switch over to using pip files. So for example, I have a requirements.txt file that has all of the dependencies that I use in my Django course. So let's say that we wanted to install those here using that requirements.txt file. So to do this, I could simply say pipenv install -r, so we want to use that -r option, and then you would specify the requirements.txt file that you want to use. Now my requirements.txt file is actually up one directory in a snippets folder, so I'm going to specify that location, but at this point you would put in the location of wherever your requirements.txt file is. So mine is up one directory in a snippets folder, and that is requirements.txt. So I'm going to go ahead and run that. So we can see that after we ran that, it says requirements file provided, importing into pip file. So it updated our pipfile.lock, updated pip.file.lock, installed the dependencies, and it's done. So now let's open back up our pip file. So I'm in pipfile.lock here. Let's switch over to pip file. So we can see here in our packages section that these new packages were added to our pip file. And those are the exact versions that were listed in my requirements.txt file. Now, if you're using pipenv, but people on your team are still using pip, then you might need to create a requirements.txt file to send to them. The pip command to display the list of dependencies that you'd use in a requirements.txt file is pip freeze. Now we can do the equivalent in pipenv by running the pipenv lock command. So let me show you this here. So I'll pull back up my terminal. Let me clear this. So if we wanted to display our dependencies in a way that we would add to a requirements.txt file, then we can say pipenv lock -r. And if we run that, then this displays the dependencies in a way that they would be added to a requirements.txt file. So this is a good thing because if your team is still using pip, but you want to move on to pipenv, then you don't necessarily need everybody to switch over at the same time. You can start using it, and features like this just make those easy to use together. And we're going to go over this lock command more in just a moment, but for now, let's move on to some additional pipenv commands here. Okay, so now let's look at how to install a package only in a dev environment. So you can imagine that there are probably going to be some packages that you'll need for a project in your dev environment that you might not need in production. So for example, let's say that we're using PyTest to test our code, but we don't actually want PyTest included when we ship our code to production. So to do this, we can simply install a package like normal, but include the dev option on the end. So I could say pipenv install pytest --dev. And if we run that, then we can see that that installed like it normally would, but there's a section here that says adding pytest to the pip file's dev packages. So let's go back to our pip file and look at this. So we can see that it didn't add anything to our packages section, but there's another section down here called dev packages, and it added pytest there. So it knows how to keep those separate, and I think that's a really nice feature with pipenv. Okay, so now let's go back to our command line, and let me clear the screen here. Now, if we ever wanted to remove any of these packages that we've installed, then it's as easy as going back to the command line here and using the uninstall command. So we can just simply say pipenv uninstall, and I'll go ahead and uninstall request. So I will run that. And we can see that it uninstalled requests and also removed it from our pip file. So if we go back to our pip file, in our packages here, we no longer have requests. It's only the packages that were in that requirements.txt file from before. Okay, so since I have this pip file open, let's go ahead and make some changes in here to see how that's done. So let's say that we wanted to actually use a different version of Python for this environment after all. So it turns out that instead of using Python 3.7, we actually needed to use Python 3.6. Now, if we're using the old way of using virtual environments, then we might need to just export our requirements and then delete the environment and recreate it from scratch. But using Pipenv is going to be a lot easier. There are actually a couple of ways that we can do this. So the first way that we could do this is that we can just come in here into our pip file and change the version of Python. So where it says Python version down here, I'm just going to change this to Python 3.6. And now we need to recreate our virtual environment since the existing one is using Python 3.7. So to do this, we can simply go back to our terminal here. I'm going to clear the screen. And now we can just tell Pipenv that the environment should be recreated using Python 3.6. To do that, we can just say pipenv -- Python 3.6. So after that's done, if I scroll up here to where we ran that command, we can see that the first thing it says virtual env already exists. So we want to remove the existing virtual env, and now it creates a virtual env for this project, and it's using now this Python 3.6.1. So if we run the Python for that environment now, so I'll say pipenv run Python, we can see that now this is using Python 3.6.1. And this new environment that it created will also be in that virtual env's directory. So if we look at the executable again, then we can see that it's still here in this virtual env directory. So that is good. So I will exit out of Python there. Now, another way that we could have done that would have been to just remove the environment completely and then just recreate it from scratch using the pip file. And if your pip file and environment ever get too far out of sync, then it might be better just to delete the environment completely and then just recreate it from scratch. So just so you know how to do that, let's go ahead and see how we do this. So I'm going to change our project back to using Python 3.7 again. So to do that, I'm going to open our pip file back up, and I'm going to go down here to our Python version and change that to Python 3.7 and save that. And now that we've changed that pip file, let's open our terminal back up. Now again, the new environment that we just created is using Python 3.6. So let's just say that we want to throw that entire environment away and recreate it from scratch using the pip file. So to remove a virtual environment completely, we can simply say pipenv --rm. So if we run that, we can see it says removing virtual environment and gives the location to the virtual environment that we just removed. Now that only removes the environment that we were using, but everything that we need to recreate that environment is still within the pip file. So to create an environment that matches the one in our pip file, we can just simply say pipenv install, and we don't need any other options. If we just run that, then that will go through and create our environment from scratch using the Python version and packages from our pip file. Now, if you ever get curious and want to look directly at your virtual environment, then you can see the path to your environment just by, let me clear this out. We can simply say pipenv --venv, and that will give you the path to your virtual environment if you ever want to look more deeply into that. Now, like I was saying before, that's just like any other virtual environment that you'd create with virtual env. So we could navigate to that location and run the commands manually to activate and deactivate that environment. So even though pipenv is nice and new, it's still mostly using the same things that you may have been familiar with already in the background. Okay, so now let me clear the screen here. Now, one really nice feature of Pipenv is that we can easily check for known security vulnerabilities for any of our installed packages. So to do that, we can simply say pipenv check. And if I run that, then we can see that it discovered a couple of things here. So first it said checking PEP 508 requirements and that those passed. But then whenever it checked installed package safety, we got a couple of Django issues here. Now, it's nice to have this feedback so that you can make the best decisions as to what you want to do with this information. So it says that these particular issues were resolved in the newer versions of Django. So we can see here that it says that this was resolved and that this was resolved, that we have 2.1 installed, but that we could install 2.1.2. So let me update that version of Django that I'm using in my pip file. So I'm going to open the pip file back up, and here with Django where it says I'm using 2.1, let's instead say 2.1.2 and save that. So now back in our command line, let's run the install command again so that it will install those changes from our pip file. So I will say pip env install, and that is going to see that we have a newer version of Django in the pip file, and it will update that for us. Okay, so once that's done, I'm going to clear my screen here, and now let's run pip env check again. So I'll say pip env check, and we can see that when we run that check now, that it says that we're all good. So I think that's a really nice addition to pip env. Now, another feature of pip env that I like a lot is pip env graph. That will display a dependency graph showing your packages and the dependencies for each of those. So let's clear the screen and run this. So if I say pip env graph, so we can see here our packages and the dependencies for those packages. So PyTZ here is listed as a dependency of Django. So if you're ever wondering why certain packages are installed or trying to debug, conflicting dependencies, then you can run pip env graph to see a map of what depends on what. Okay, so now let me clear my screen here. Okay, so we're almost finished up, but let me show you an example of what you do once you're ready to push your code to production. So currently, our installs have been using the pip file to create our environment. But if you remember, I said that the pip file isn't deterministic, but the pipfile.lock is. So what I mean by that is that the pipfile.lock has the exact hashes and versions for specific packages that we're currently using in our project. But the pip file might just tell us to grab the latest version of a package. Now, getting the latest version is fine in development, but when we push to production, we want to know that we're pushing the exact versions of the packages that have already passed all of our testing. So once you've tested all of your code and you know that you're ready to push what you have so far, then you can create or update the pipfile.lock with the current dependencies by saying pip env lock. And we can see that it says that it updated that pipfile.lock. So once that's done, then you can take your pipfile.lock and move it to your production environment. And once you're ready to install everything that's in your pipfile.lock, then you can simply run the command pip env install and then -- ignore -pipfile. And that will create an environment using what is in the pipfile.lock and ignore the pip file that is usually used by default. Okay, so we're almost finished up here. There is one more thing that I wanted to show because it's something that I personally look for when working with tools that create virtual environments, and that is the ability to set environment variables that are specific to the environment. Now, this is something that some tools overlook, but I think it's extremely important. So for example, if you're working on multiple Flask or Django projects and want to have environment variables for each project that contain the project's secret key and database connection information and things like that, then it would be nice to have the virtual environment handle this without needing to do that manually. So the way that we can do this using pipenv is to create a .env file within your project directory, and you can set that environment variable within that file, or multiple environment variables within that file. So let's create this and see what this looks like. So I'm going to open my Sublime Text here, and within Sublime Text, I know that this is a little hard to see over here on the left, but I'm just going to click on my project directory and say new file, and I want to call this file .env. So we will create that, and now within this .env file we can add our environment variables that we want to be accessible in our environment. So for example, let's say that we had a secret key. So I can say secret key is equal to my super secret key, and now let's save that. So now that I have that saved, I can go back to the command line here, And now let's see if we can see that environment variable within our environment. So let's run Python from within our environment. So to do this, as we saw before, we can say pipenv run Python. And we can see that the first line here says loading.env environment variables. Okay, so that's a good sign. So now let's try to look at this environment variable. So to access environment variables within Python, we can use the OS module. So I'll say import OS and then os.environ, and we can access that environment variable. So we called that secret_key. So if I run that, then we can see that we get the value, my super secret key. And that was the value that we set in that .env file. Now again, if you're wondering why this is useful, like I was saying, you might have multiple projects that all have the same environment variable names. So for example, Flask and Django projects are most likely all going to have secret keys, and you don't want to manage all of those manually. It's better to just put them in a .env file specific to that project. Now another thing is that you do not want to commit those .env files to your repository. So if you're using Git or something like that, then you're most likely going to want to add that .env file to your git ignore file because you don't want to commit it for other people to see, because it's could possibly have sensitive information like, you know, database connection strings and passwords and things like that. So just a tip, that's something that I use a lot, is those environment variables within different projects. Okay, so I think that is going to do it for this video. Hopefully now you have a good idea for how pipenv works and how you can start using it on your projects. I actually like this tool a lot and will most likely be using it instead of pip and virtual env for most projects from here on out. Now, a lot of people are doing the same, so it'd definitely be beneficial for you to learn this also. But if you have any questions about what we covered in this video, then feel free to ask in the comments section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.